I'm Jason Menard with Coloquia. It's a company based here in Uruguay and también en Estados Unidos. My talk's going to be in English because if I speak in Spanish, you'll probably make fun of me the rest of the day. I learned Spanish from 3-year-old and 4-year-old orphans in Honduras, and so I talk like an orphan basically that has really bad grammar, and so I won't torture you now. Okay, so I'm going to talk about Elasticsearch. This is a fairly short talk to cover something as big as Elasticsearch. So I'm really just going to talk about where it fits in the universe of data stores and things that you use to manage or access data, to give you an idea. And then you need to look at your own business and your own needs to figure out where it fits for you. But I'll try to give you a general idea. So what's so special about Elasticsearch? This is probably the shortest way you can describe it. Elasticsearch is not just a search engine like most people think from its history, being based on Lucene, kind of coming out of the project called Compass, competing with a project called Solar. Elasticsearch kind of came from the world of search engines, but that's not all. It does a lot more than that. It also does analytics, roll-ups, aggregations, can do statistical analysis on the fly. And also people use Elasticsearch for doing big data processing as well, using it both as a source and a target for storing that data. Usually in Elasticsearch, you store JSON documents, and they may or may not have a schema. And the reason I say they usually have a schema is because most of the time you do want to know what your documents look like, at least for the fields or the parts of the documents that are important. So if you want to search for something, or you want to facet on something, or you want to sum or do analysis on something, you typically want to tell the engine about it, but you don't have to. So that's why I say usually. I think most of the real use of Elasticsearch defines some sort of mappings or schema for the documents. And it's typically not the place you store your only copy of an important document. Elasticsearch is usually a copy, a denormalized version of your other data. Although it can be used as a source of truth, it usually isn't. And I'll talk about why a little bit later. So there's a lot of buzzwords that go into it. If you look at the introduction page for what is Elasticsearch on elastic.co, you'll see these and more. It's document-oriented, it's real-time, sort of. I'll explain that in a bit. High QPS is really important, queries per second, because with a database, you can tend to crush it if you're doing maybe 1,600 queries per second. Or like our system right now is probably doing 800 queries a second on a 2-node cluster just to look at what someone might be looking at in Google search. It's doing 1,600 per second looking at what to recommend to you. It's doing 5,000 per second doing queries about other things related to what you might want to do next. So if we did that on our database, we'd probably kill it, or we'd have to scale it quite differently. So it's designed for this. You can scale horizontally. It's distributable. It's highly available because you can have many copies of it. It can deal with many concurrent copies of data and nodes and backups and replicas. And everything else there are some of the basics of it. I won't read this to you. These are things that you can quickly find out yourself. I'm going to talk about other aspects of it. One key thing here maybe to point out, I actually have a pointer. The REST API accessible is typically how you'd access it from most languages that don't have a binary version of a client. So for example, from GeneXus, you'd use the REST API. So when do you use it? When you have complex queries and filters, this is where it really shines. So instead of having something with simple 2 or 3 filters, like select something where the country is Uruguay and the city is greater than 10,000 people, that's a pretty simple query. But when I have 2,000 predicates, maybe I'm querying for all the individual different separate small locales within the country individually, and they don't have some higher level grouping, I can do that with Elasticsearch. I can have 10,000 items in a term list to say, is it in that list? I can combine that with many other filters. And in fact, the more restrictive your filters get, the faster Elasticsearch gets. So instead of slowing down like some other systems when you get more and more complicated, it finds the most restrictive, the fastest filter that you are providing, and that guides the whole query. So it actually accelerates it. So I can do geo-based queries combined with kind of linguistic type queries, combined with statistical rollups in multiple levels using parent-child relationships. And I can do that in 20, 30, 50 millisecond type queries just fine. So millisecond responsiveness is important. Fast, quick, real-time access for your users to see their data. It also shines when you're doing dynamic scoring. Instead of just sorting by something that's in my data, I may want to evaluate the query versus the data. So did my query contain certain tags that happen to be my data, elevate that particular documents? Did I use some sort of stem of the word or the actual word, elevate those that match closer versus those that match looser? Is the word more rare or is it more significant? Make those documents come forward. So you can use those same type of things we use in full text search to do relevancy to also do metadata-based scoring. And it can be based on what's happening in your query at the time. So it can be quite complicated. So instead of just typical sorting, you can do that as well. So you can do aggregations on really large numbers because you can scale horizontally. If you shard your data among many different nodes, then that increases the amount of documents that you can process in any given aggregation. So if I look at something like a BI system or like Redshift or Spark SQL, Hive, I can do big queries on big amounts of data, but I'm going to wait 7 seconds, 30 seconds for a query to come back. With Elasticsearch, you tend to scale so your query time is consistent. If I want 300 millisecond queries, I will scale to get 300 millisecond queries. I can control that. In other systems, you don't always have that control. You can increase your node size, and eventually you hit some limits or balance points, so you can't shard enough, and then you're done. So I can combine these different things together and still keep my performance level by scaling horizontally in both terms of the number of documents or in the terms of computing power that I want. So the difference between 10 nodes and 100 nodes, you lose a little bit, obviously, as you scale horizontally, but it's a few percentage of performance. It's not a massive loss. So it scales really, really linearly as you add machines. So you have to use Elasticsearch in a way that helps Elasticsearch too. If you go and use the product in ways that are evil and mean, it's not going to perform as well. So you typically want to prepare your data in a format that's beneficial for Elasticsearch. So one of the examples of that is denormalizing data instead of doing joins. You can do 3 different types of joins in Elasticsearch. Basically parent-child, parent with the child indexed inside of the document, and next to the document. And those are really hard to explain the differences, but I have those options, but I don't always want to use those. I can denormalize and have a zero-cost join by doing that instead. And I can also do tricks with like multiple indexes. So multiple indexes might be that my data that hasn't changed in a month is in one set of indexes. My data that's changed the last 2 weeks is in another, and all my daily changes for the last week are in yet another set of 7 indexes. And by doing that type of division, I can control which indexes are involved in any specific query. So I can remove things that I don't need to waste time on. I can include things that aren't changing, which the system can basically query at a higher performance than things that are changing. And then I make the things that are changing much smaller, so the cost of change is much smaller. So typically, that's the type of things you do with Elasticsearch to help the engine out to get the most performance. So if I don't do these things, I can obviously make bad performing queries. I can make it perform slower than my MySQL database or something else. But if I learn these type of tricks, I can go to really, really high levels of scalability. So can a database do all this? No, but kind of yes. It depends on your scale. At certain scales, everything can do anything. You know, I have a camioneta. So I use that to drive from Villa Serrara to Montevideo. But then I have to work on my land where I have grapes. So I have a little tractor. I don't use my camioneta for that. And then when I go out with my friends on the weekends up in the Sierras, I use a quadricycle. They all move. They could all go to Montevideo, but they're quite different in what they're for. And Elasticsearch is the same type of thing. There's a space for it that works really well, and a database doesn't fit as well. So you use your database typically for your source of truth, the original copy of a document, the durable thing you want to keep forever, where you need transactions, that multiple tables that are updated in coordination. So the typical example of pulling money from one bank account, adding it to another, you don't want that to be lost, so you need a transaction. Where you want data integrity and the ability to join across relationships. So one table relates to another, and you want to guarantee that relationship. Either at development or production time, you still have that ability with a database. Elasticsearch doesn't try to do those things, and it doesn't want to do those things. It's not trying to be a database replacement. So typically, it'll sit alongside your database, and it'll take over certain duties that your database doesn't do as well. Some of the things I mentioned before. So some of the 3 typical areas of data and data processing that you do: the durable database, NoSQL store for like your online transactional processing, reporting, then sync in a copy of some of the data into Elasticsearch for high QPS, queries per second, scored queries, complex filters, aggregations, analytics, and so on, where I want smaller sets of results. So I may be aggregating 1 billion records, but I'm producing the top 20 contributors to something, or the top highest revenue generators. So I'm getting down to a smaller number from a very large number. So that's a key point here. If I want to query 1 billion records from Elasticsearch, it's going to be more painful. But if I'm looking for something, no matter how complicated that search is, I can find it very quickly. And then data warehouses or big data systems for doing the more offline meaning for me, anything that you don't get back in a second is offline. For our type of system, we have to respond before the user is bored or thinks something's wrong with the system, which is usually less than a second. So offline is anything bigger, longer, unpredictable, is my definition for offline. And in our case, at Coloquia, we use all three of these. We have MySQL. That's actually, we listen to the replication logs of MySQL, and then we feed some of the data into Elasticsearch, a lot of the data into Amazon S3, some of it into Redshift. Then we aggregate that into Spark SQL, and we generate other data that goes back to any of those different sources. So they all work well together. They're not exclusive, one excludes the other. That's not the case. So can Elasticsearch be a primary data store? Because sometimes you get annoyed that you need a database and a search engine or an analytics engine. So, and we've been through this conversation almost every startup I've done since the first days of Elasticsearch. So since like one of the alpha 0.19, I think was one of the first ones, we had this conversation, and every single project since has had this. So you can do it, just like you can with any NoSQL store. MongoDB, if you trust it enough, if you don't think it's going to lose your data, you can use it for your primary store. It may or may not prove you wrong, and it's getting better over time, and probably is fine nowadays. RethinkDB, has it been proven or not? I don't know. OrientDB, another one. So you have to make this decision for any data store. For Elasticsearch, they're always improving durability. It's a high focus of the team. From the 1.x versions of Elasticsearch, 2.x, they actually went out and got tested with a system that just tries to beat a distributed system into the ground looking for holes, and they found holes. And they fixed a lot of those. And then now in their new series, which is 5.x, small version jump there, they continue to work on that. I rarely have seen data lost in Elasticsearch in probably the last 2 years. And usually it's some sort of error on our part for how we did the cluster or an in-memory cluster. We intentionally have the risk for data loss, but we know we can reload it. So they continue to work on that, but they don't guarantee it yet. And they're not trying to yet, but they will. There's no transactions, so you have to work in a system where you can update things independently. If you can't do that, you need a store that can do transactions. Data integrity I mentioned before. And then the last piece, Elasticsearch is real time and it's not. Real time meaning that if I store a document, I can fetch the document and I always get the correct copy back instantly. But I can't query and search that same document in real time. I can do it in near real time. So Elasticsearch has the concept of a refresh delay. Every time you refresh an index, it has to reload caches into memory because search engines work by holding a lot in memory. They remember filters. They remember things you faceted on. They load filled values in so they don't have to go to disk. Although newer things like doc values and other techniques are allowing it to work more from disk at almost the same speed, they still have to keep things around. So if you change a segment of an index, it has to reload that, refresh it, and possibly rebuild those caches. So there's a cost. So the refresh delay is you deciding how short to make that, taking a hit in CPU and performance for reloading, versus how long, meaning my data is slightly stale. So you have control over that, anywhere from 1 second to whatever you want it to be. And in our case, we have indexes that range the gamut. From 3 seconds is probably our shortest, up through things that are 10, 15 minutes on refresh delays. So you have control over that, but you need to be aware of that. Because some people say, why isn't it there when I search? Well, do a get, and it's okay. And a lot of times your application is okay with that. Certain pages that do CRUD type actions, get and put, they're fine, they're real time. Searching for users that you just added to an org may have a slight delay. But there's tricks to work around that, just like you would if you're doing, for example, MySQL replication. We have a replication delay. If you switch from the master to a slave, your data may not be there yet. So it's a similar type of problem, but it's on the master as well, not just a slave issue. Okay, so you can, many people do use it as the source of truth. We have some data that we store only in S3, S3 is the Amazon file system, so it's basically a big disk with a bunch of objects in it, and we store it in Elasticsearch. Because we know if we lose the copy in Elasticsearch, we can reload from the last snapshot and reload any changes from S3. Even if we take an hour hit, it's the type of data we're okay with taking an hour hit on. Maybe it's log files, or maybe it's your activity as a developer for the last 4 hours, which we don't really process as much. We more likely use your historical data. So there are cases where you can use it as source of truth. So what else about it? Those are the common things that people can find easily about Elasticsearch and most people talk about. You know, where does it fit in the world? Should I use it or not? But it does 3 other things really well using really simple tricks. So Elasticsearch has aggregations, and aggregations allow you to do kind of like a group by. But they're a little different because the group by with bucketing, which some data warehouse or some big data type databases can do as well. But it can do any nesting levels of these that you want. So I can, for example, bucket by dates at 1-week intervals. Then it can add up all the users to find the top 10 users and then find their most significant traits for that time period versus everyone else that's been doing the same activity that's not in the top 10. That's a pretty simple aggregation in Elasticsearch. It's just nesting a few aggregations together and basically asking the question. So using those aggregations for things like analysis or reporting is great. That's what most people are getting to use now. If you look up Kibana, you'll see that people are doing log file analysis with Logstash using that. But you can use it for other things as well. And these are 3 less common things. And if you get a copy of the slides, which I think they're distributed, yes? People find these somewhere? Okay. These 3 links will take you to some documentations describing these. And I'll just verbally describe a little bit here. So no, significant term aggregation allows you to find mutual information, relationships between data. So things that stand out, the signal versus the noise, things that have relationships and occurrence. This occurs 70% for you, 30% for the background. So it allows you to do comparisons of how often things occur. And so depending on how you design your data, you can use this for things. For example, I use significant term aggregation to find in a list of skills that a teacher might give to a student, like a skill test, being able to work with 2 triangles and do geometry, being able to add 3 numbers, whatever that skill description is, to find the 2 words that really identified each skill the best and weren't available in any other skill. So I could find the 2 words that basically uniquely identified each one on the fly. So no matter what they picked, whatever skills they listed on the screen, you get a nice 2-word description that reminded you of what the skill was. That's an easy case with significant term aggregation. I just take the skill I'm looking at versus all the other skills and say what's unique about it. And then I can filter against what the other ones had that were unique and make sure I get something different. Another example of significant terms would be something, I don't know if anyone saw the Cloakia demo with Pablo Brenner. Anyone see that the other day? Okay, 1 person, 2 people. I don't know if he showed the comparison of developers. Cloakia identifies what developers do every day and can tell you basically when you might need help. It can make recommendations for content, for documents, for Stack Overflow articles. And one of the charts in there is it shows you what is different about this developer versus another, their skills, their strengths, not just from asking them or interviewing them, but by watching their behavior. That's all done as Elasticsearch trick. That top line, you could do that query very easily. It looks more impressive, but with Elasticsearch, it's actually quite simple. If you compare using significant terms query a developer versus the industry of developer information, it'll tell you what stands out, what's unique about them. If I take words that they use in their conversation or coding patterns that they use and ask the same question, I can find out what they typically do more or less than other developers. And you can do any comparison of sets between 2 sets, which is the second one. Multi-set analysis. I can do comparisons between any 2 sets of data that I want. Then I can take the sum of that and compare it against another set, the sum of that and compare it against another set. And I can keep nesting my aggregations to do these type of comparisons. So multi-set data analysis is really fast. We do these queries in real time. We fill out the chart as you're sitting there looking at it. And it's all done live. And the last one, graph exploitation of data. I think I can. So Elasticsearch has a new feature that you'll be hard to find and get to because they provide a demo version, but then it's part of the subscription plan. So you can pay a lot of money to get this feature, which is basically exploring your relationships into data without telling them what the relationships are. And so a lot of people are paying a lot of money to Elasticsearch company for support contracts to get to this feature. But this is really the same thing I talked about before. They're doing significant difference aggregations to find what stands out between two sets of data and using that to recommend it as a link between the two, then looking to see if it actually is in the other data, and then they draw it on the screen. So they're really building this whole high-level product on the really simple concept that you can do yourself in Elasticsearch. But it's another feature. You can do graph exploration. It's not the same as a graph database, so don't compare it to Neo4j or TitanDB or OrientDB. It's not a graph query, but it allows you to go through relationships that actually aren't defined by, for example, referential integrity. So graph exploration is another part, and all these are really based on the exact same set of features, which all start from significant term aggregations. So if you follow these links, you'll see some great tutorials on how to do, recommend the best movie someone should watch if they're a sci-fi nut, those type of things, or find the highest rate of criminal activity in a particular area of the city. All of that you can do very easily with 20 lines of Elasticsearch query. And typically those are things people think of as big data science, big data Hadoop type of tasks, but go read these things if you're interested in that type of stuff, because you'll find out it's really, really quite simple. So one thing that's really nice about Elasticsearch is you can try it in minutes. This isn't something that you have to plan a week to get into. You can basically, they give you books online for free. They have the 2 books at least for Elasticsearch that are available free online that are really quite good. One's for the 1.x, one's for the current version. Actually, I think it has both. So they have books online. They also have great tutorials. They have sample sets, for example, the last page where I just mentioned the significant terms query. They have really simple examples you can do in a few minutes to try those things out. Loading your data is quite simple. If you can create a JSON document from your data, in a couple lines of code, you can have it in Elasticsearch. And if you do that, the payoff's usually pretty fast. Most of the time when people mess with Elasticsearch and don't get anywhere, it's because they don't know where they're headed or what they're trying to get from it. But if you have a sense of that, you typically can go very quickly to have something working that's scalable, that gives you something big in your application that you didn't have before. So very small development effort, very large payoff. Any questions?
Fast, because I work in a company, a money company, a financial company.
Sí.
I do the compliance queries of international list with this tool. It's a great tool.
Great, great. Yeah, I think if you go to look for a search engine and you're comparing Solr and Elasticsearch, start with Elasticsearch. It's a much easier starting point. It's easier to use, easier to manage. You can run on your laptop. It's like a 300 meg download and you're off to the races, ready to go. And I think most people usually have a story like that, where, yeah, I'm using it, I like it. Once they get past the first few days and you get the concepts, it's very quick, I think, to learn. It's one of the easier ones. It's kind of it's a very intuitive system, so don't fear it. If you have any idea you want to use it, give it a try. Okay, thank you. Enjoy your lunch.